Right, so in this question here, they tell us the information about the masses of these, and it says, right, that this particle B is projected with a speed of 8 meters per second at an angle of 90 degrees, okay, also horizontally. Now when it says horizontally, what it means is on a horizontal surface, and that's true with all of these impulsive attention questions, right, so all on the flat, okay, and you're looking down on it, right, it's important to remember that you're looking down on it always, okay, so when it says horizontally, that's what it's saying, but then when it says angles 90 degrees to the line that's joining A and B, it means we're going this way, okay, because that is perpendicular, isn't it, to A and B, we're going perpendicular to it at 90 degrees, okay, so that's the way it's going. So we think of this as horizontally, don't we? But when you're looking down on it, that's what it's trying to say, right? You're looking down and it's going this way, okay? Now, of course, we know that distance between them here, right, is L, isn't it, between A and B, right? And that's when you've got your string all slack, right? So it's slack here, isn't it? But then, of course, it's projected, and of course, it will become then taut, okay? It's projected this way. Remember, then it will become taut when A and B are joined up, like that, when it's 2L, okay? So it's loose at the moment, but it's projected this way, and it's going to become taut when the length of it is 2L. But don't forget, this distance here is still going to be L, isn't it, between B and A. This sort of, I don't want to call it vertical because we're looking down on it, but this sort of distance here is always going to be L because it's been projected this way with speed 8. All right. Now, what's going to be important is to recognize that just before it gets taut, right, you've got this speed here of 8 meters per second. But remember what I've said before, when we resolve, right, when we look at change of momentum and so on, you have to resolve along the string, okay? Have to resolve along the string, and of course perpendicular to the string, okay? So important, along the string and perpendicular to the string. Now, we're going to call this theta, I would say, because it's inside this sort of triangle that's been formed, okay? And I can work things out there. And if that's theta, of course, this is going to be theta here. So then that's going to be 8 cos theta. That's going to be 8 sine theta, okay? That's what we're going to have there. And we can work out what theta is. In this case, we need cos theta and sine theta and so on. So sine theta, I think, is easy to work out there because it's opposite over hypotenuse. So L over 2L, which is equal to a half. Okay. Of course, if sine theta is a half, theta then is equal to 30 degrees. Okay, so we can work that out there quite nicely. Cos theta we'll need as well, of course. So cos 30 degrees, isn't it? Because I know theta is 30, that'll be root 3 upon 2. Okay, so now what we need now is the before and after situation. Okay, that's really important, before and after. So there's A and B. Okay, the before. So of course, at the beginning there, A, which is mass 3 kilograms, don't forget, doesn't move, okay, just as is being taught. B, of course, has the components, okay, well, it's got a component of 8 cos theta along the string. Now, cos theta, cos 30, of course, is going to be, we worked it out, it'll be root 3 over 2. So that'll be 8 times root 3 over 2, which is going to be 4 root 3. And perpendicular to the string, okay, it's going to be 8 sine theta. Well, sine theta is a half, so that's going to be 4. Okay, so that's before. After then, of course, if you remember after, well, A will start to move, okay, because A is, remember, 3 kilograms. Okay, what was B again? B was equal to 2 kilograms. Okay, but after, A, of course, will move, but it'll move along the string only, so it moves speed U. B will change in speed, okay, B will change because, of course, there's a sort of a jerking, that's with the string, which is going to sort of pull it in a certain way. Oh, we can have it going this way, I don't know why I put it that way. That's the sort of way it's going to go, it doesn't matter really. But we're going to have U there, yeah, it's going to be the same along the string, and we're going to call this V here. Alright, so let's have a look here, let's have a look at what we've got. Well, if we look at conservation of momentum, right, we're going to have along the string, to start with, we resolve using conservation of momentum. Along the string, we'll have some momentum before. It's going to be 4 root 3 times 2 kilograms, and there's nothing there. Equals then momentum after, so we're going to have 2 kilograms times U plus 3 kilograms times U. Okay, you could have called it V, right? Maybe we'll call it V actually, because we've called it V in other questions. We'll call this W, isn't it? Not to confuse things, right? So V there, U, and V there. That makes so much sense, doesn't it? W there. So that would be 8 root 3 equals 5V. So then V will equal to 8 fifths. 5. We've got 8 fifths here, root 3, isn't it? Which is 2.77. Now, if we do perpendicular to the string, okay, right, we'll have, so perpendicular to the string, we'll have this one before, which was 4 times 2, okay, and that will equal then, well, of course, there's nothing in this way, it's moving along the string, this will be 2 times W, okay, so that implies then W is equal to 4. Okay, so we need to get the speeds. Now the speed of A is easy, okay? Speed of A is just going to equal 2.77. Speed of B will of course equal, you've got to use Pythag then, right? To get, of course, you're going to square 2.77 plus then the perpendicular component 4 squared. That works out to be 4.87 meters per second. It then says ask for the impulsive tension in the string. Now remember, impulsive tension is just a change of momentum that occurs to one of the objects. Okay, so how it affects the object is what's going on in the string. So we'll do this one, so it'll be 3 times 2.77, take away then momentum before, which is 3 times 0, so you get 8.31 Newton seconds.